Hello, and welcome to my presentation of the physics of muscles and weightlifting. We can break the basic elements of physics down into the four main forces: gravitational, electrical, weak nuclear, and strong nuclear. However, when we're dealing with the body, we're only going to be discussing gravitational and electrical forces. To understand the physics of our muscles, we must understand the electrical charge behind our muscles that allows us to move. So the forces produced by our muscles are because of the electrical charges that are produced by our cells. Each cell across our body has a different electrical charge due to positive and negative ions within and without the cell. When these ions are attracted to each other, this is what creates the electrical charge that allows us to contract our muscles and allows us to move. Another important force on the body is the gravitational force, which of course is definitely weaker than the electrical force in our muscles by 10 to the 39ths. Gravitational force is important to our mass and the way that our blood travels around our body, and especially to the formation of our bones. Another important force within the body is the frictional force. This often occurs in different coefficients within the body, such as between the tendon and the sheath, which is 0.013, and the bone joint, which is 0.003. As you can tell, this force is much smaller than the gravitational or the electrical force. However, it is very important to the way that our body functions. Moving on from the fundamentals of muscles, we can now classify our muscles into two different types. Striated muscles tend to have these fibers, which are striations in the muscle that we can associate between dark and light bands. The fibers within these muscles are what connect to tendons, and the tendons are what creates muscle bundles, such as your triceps or your biceps or your triceps. The other type of muscles is the smooth muscles, which are absent of the striations and tend not to be as important as our striated muscles, which are what allows us to voluntarily move our muscles. Smooth muscles are the muscles that we associate with non-voluntary movements, such as your lungs or your heart, which tend to move on their own. Here we can see our arm. These two are different types of muscle bundles: your triceps, which are in the back of your arm, and your biceps, which are in the front of your arm. The triceps act to move your arm downwards, while your biceps act to bring your forearm up. When we further examine all of our muscles, we find myofibrils, and when we go even further, we find filaments. And these filaments are made up of proteins. There are two different types of filaments. We have thick filaments, which are filled with the protein niacin, and we have thin filaments, which are filled with the protein actin. When our muscles contract, an electrostatic force slides the thick and the thin filaments together, and this is what ends up shortening our muscles by 15 to 20%. Here we can see our two proteins, actin and niacin. When this electrostatic current goes through our muscles, these two are pushed into the actin, which allows our muscles to contract and shorten. Now that we know the basics of our muscles and the way that they move, we can now discuss the physics of our muscles. So basically, we have levers within our body, and levers can be defined as first class, second class, and third class. Now within the body, third class levers are the most common, and that can be determined or shown with our joints and the way that our arm moves. The force of the arm here, our fulcrum, and then a weight in our hand. Now we can find the force provided by our biceps here that allows our arm to move this weight upwards. First, we start with the torque. So we sum our torques around our pivot point here, which is our first step. So our torque 1 would be due to the weight in our hand here, and we'll say that that is about 30 newtons of force. Our second torque would be the muscle force that is bringing our arm upwards, and we'll say that is about 4 newtons. Our second step is to find the equilibrium. The force of these two must be the same to move our arm upwards. So our M must equal our W. So if we have 4M here is equal to 30, our M must equal 7.5 to equal 30. So the force that our M must move with is 7.5 newtons to raise this weight upwards. Another important factor of calculating the torque of this and this is the angle, which we can attribute to alpha. Now, once you do the calculations, which I won't be doing because I'm not that smart, you find that M stays the same as the angle of our arm changes. So the force that this applies always stays the same as this moves up and down. And as these muscles shorten and lengthen, the force that is provided here must change. And as this muscle shortens and lengthens, there's two extremes at which it can function. The extreme of it being all the way up and the extreme of it being all the way down. At the place in between these two extremes is where the muscle can function in its best form, providing as much force as possible. However, don't get this mixed up with the angle. The angle of the arm is not what is affecting the force applied, but is the length at which the muscle is contracting. To further understand the way that our muscles work under these extremes of contraction, 0.5 contraction would be all the way up, and as you can see, our max force produced is very low. 1.5 would be all the way extended, and our max force is also very low. This 1.5 length would be about resting at 100 max force. Now we can discuss the topic of building our muscle. So when you work out, tiny little tears are made inside of your muscles, and this is called hypertrophy. Basically, these tears inside your muscles are filled with proteins during the resting period after you work out, which is why you see people tending to drink protein shakes, because this is what builds up the protein inside your body and makes those tears build muscle. We can now account this to the equation of F equals ma, force equals mass times your acceleration. As your mass is increasing, your force is increasing, or the ability that your muscles can produce this force to a greater extent. Hey, it's Austin. I forgot to put an end to this video, so you guys know all about the muscles and how physics works. I hope you enjoyed my video because it took me a lot of time to set up the stupid stand for it. Okay, bye.